All right, so there it is. There's my system. I want to find the point where those two cross, and I have to use elimination. I don't get to do anything else. What are you thinking?
I was just going to ask, would you have to add that or subtract that?
Well, if I were to add it, what would happen?
You would add, there would be no elimination.
Yeah, nothing gets eliminated. 2x plus x is 3, and that's... Yeah, the goal here is to have a variable drop out.
Okay. I wasn't sure if you had to multiply or plus and add.
Right, well, and if I were to subtract even, which try not to do. Try not to subtract, always do addition. You'll make less mistakes with your signs. If I try to subtract, though, even that won't eliminate. But what if this was a 3 instead of a 1? Then I'd have something that gets knocked out.
So you subtract 3 from this.
Not quite. What I'm going to do is take this whole equation and multiply it by 3. And you say, where did the 3 come from? Because that's usually what gets asked. The 3 comes because when I look at it, I know my plan is going to require this to be a 3y so that they're eliminated.
Okay.
You have to project forward, say, what do I need to multiply one of the equations, or sometimes both of the equations by, in order to guarantee that something is ready to be eliminated. You also want to be sure when you do this that you multiply every single term by that 3. It's not just one, and it's not just the other. It's everybody. They all get it. Now I can add them. And now when I add them, 5x, no y's, equals a 5.
X equals 5, or would it be an addition or minus? Or would go with the original problem?
Stay with the original problem. So yeah, you always want to try to add them. And now I can solve that guy without too much trouble. Just divide each side by 5. And I'm left with x is equal to 1.
Why do you multiply by 3?
I multiply by 3 again. The goal was to get this. See how those two are set up to be eliminated?
Yeah.
The only way that happened was because I picked out 3 as what I did to prepare it.
Yeah, when you have x equals 1, do you plug that into the second equation that you changed, or the first?
You can plug it into any of the 4 equations up there.
Oh.
It'll still work because they're all true statements for this situation. So that number can go into any of this or any of that or either of these, and it still works. I would go after this one because it's got the least stuff in it, and that makes it the easiest to solve. Subtract the 1 from both sides. Y is 2. 1 comma 2 is my final answer. CJ, do what you got to do. Sid, what's up?
What if the number was like for the second one, it's like x plus y equals like 9 or something? Would it be times 9?
Yeah.
Okay. And then
Well, no. That 3 and that 3 have nothing in common.
Oh, no.
Nope, that 3 is there because of that 3. I have too many 3s in this problem, I think. Yeah.
You wanna know? No.
Yeah, that's a good with a different number. Yeah, got it. Before I do that, though, is there a question on this one? Okay.
Yeah.
Shoot.
Well, like, you know when you multiply by 3?
Yeah.
Can you just pick any number?
You
or-
pick the number that sets up this situation here in red.
Okay.
You want to have it set up so that when you add them, where'd the y go? It went.
Technically, it's not.
Are the x and y always